Hi everyone, this is Babaiah, Assistant Professor of ECE Department, MLR from Hyderabad. Today I am going to explain about the time domain specifications. In previous lesson, we have learned the based on the damping ratios, what are the systems are available, what are the responses for the each and every system. All these are we learned from the previous lectures, and now today we are going to learn the time domain specifications. Right, coming to the today our session overview, just what are the definitions of the time domain specifications, or what is meant by time domain specification, what are the time domain specifications are available in time response. Here see, one is the delay time, and next one is the rise time, and third is the peak time, and here fourth one is the maximum peak overshoot or else maximum overshoot, and fifth one is the settling time. All these are the time domain specifications. Here now we are going to see the one by one. Here see, the transient or else time domain specifications is nothing but the transient response characteristics of control system. Here see, the transient response characteristics of a control system to a unit step input is specified in terms of the time domain specification. The characteristics of the transient response. The transient response has some time domain specifications like delay time, rise time, peak time, maximum overshoot or maximum peak overshoot, and settling time. All these are mentioned in a single graph. This is the underdamped second order system response when we are going to apply the unit step input. See here. Here the second order system unit step input. This is the output. Here observe. Delay time is there here, TD, and rise time is T suffix R, and peak time is T suffix P from here to here. And next this is the settling time, and here last one is the maximum peak overshoot. All the time domain specifications mainly here in this figure we are representing all the time domain specifications, right? So the time response up to the settling time, this is time response up to the settling time. This is the known as the transient response, and the response after the settling time. After the settling time response is going to be the steady state response. Here two parts in a time response. One is the transient response and another one is the steady state response. Here transient response and steady state response. Transient response is nothing but from the figure the response of the system up to reach the settling time, or else before the settling time the response of that system is known as the transient response, and after the settling time we are going to observe the steady state response. Now I am going to explain each and every definition here. Coming to the delay time first. Here see, delay time, it is representing with the T suffix D. It is a delay time, and what is the definition of delay time is nothing but it is the time taken for the response. Here observe, delay time is there here. Delay time, the time taken for the response. This is the C of T is the response, and with respect to T, this is underdamped second order system for unit step input. Unit step input here, delay time is nothing but it is the time taken for the response to reach the 50% of its final value, or else 0.5 of its final value for very first time. 0.5 or else 50% of its final value. That is the delay time. Here we are going to represent T suffix D. What is the formula for the delay time is here 1 plus 0.7 zeta divided by omega n. Here 1 plus 0.7 zeta by omega n. This is the formula for delay time. And here next coming to the definition of rise time. Here see, rise time. Rise time is denoted by the T suffix R, and it is the time required for the C. Observe in this graph, rise time here T suffix R is there. Rise time, it reaches up to 1 right here. So it is the time it is the time required for the response to reach or rise from 0 to 100%. 0 to 100% of its final value. Here 0 to 100%, that is 0 to 1. So 100% means here 1. So 0 to 100% or else 0 to 1 of its final value. This is the applicable for the underdamped condition only. For underdamped system, the time required for the response to reach or rise from 0 to 100% of its final value is known as the time or rise time, right? Rise time. Here see, observe, for rise time for the each and every system, we have a different values are available. The rise time for the, here see, first one, the rise time for 0 to 100% is for the underdamped condition. For underdamped system, 0 to underdamped system, 0 to or 0% to 100%, 0% to 100%. Or rise time for any damped or else a critical damped system, here see, observe, 5% to 95%, or else over damped condition it is 10% to 90%. Here observe, the rise time is calculated from the 0 to 100% for the underdamped, and overdamped system 10% to 90%, and for critically damped system it is 5% to 95%. Here TR or rise time for the overdamped system, for overdamped system 10% to 90%, 10% to 90%. TR or rise time for the critical damped or critically damped system, it is the 5% to 95%, 5% to 90%. These are the different time response or rise time values for the each and every damped systems. Underdamped or overdamped or critically damped system, the damping zeta value based on the damping ratio, the system can be classified underdamped or overdamped or critical damped or undamped, right? Here for the underdamped system, the rise time is 0 to 100%, and overdamped for the 10% to 90%, and critically damped 5% to 95%, right? All these are the rise times for the each and every system or damped systems, or underdamped, overdamped, critical damped, right? From this figure we observe, right? Next, coming to the peak time, it is representing with the T suffix P. It is representing with the T suffix P, is nothing but the peak time, and it is the time taken. It is the time taken for the response to reach the peak value of the very first time. Peak value, here see, observe, peak time, C T suffix P, this one is from here to here, this one, this is the peak time, right? So peak time is nothing but it is the time taken for the response, to reach the peak value, right? Reach the peak value the very first time, or it is the time taken for the response to reach the peak overshoot, or reach the peak overshoot. Both are also one of the definition for the peak time. See here, it is the time taken for the response to reach peak overshoot. Peak overshoot, M suffix P, is reach the time taken, or time taken for the response to reach up to maximum overshoot, or else peak overshoot, that is M suffix P, is known as the peak time. Simply peak time. Here see, the formula for the peak time is here, peak time equals to T suffix P equals to 5 divided by omega d, 5 divided by omega d, where peak time, the damped frequency oscillation, here where is omega d is nothing but the damped frequency oscillation, that is omega d equals to omega n into under root 1 minus zeta square. Omega d equals to omega n under root 1 minus zeta square, under root 1 minus zeta square. Here peak time t suffix p is equals to, in place of omega d, just substitute omega n into under root 1 minus zeta square. This is the peak time formula. Here, next here, maximum overshoot or peak overshoot. Here rise time formula is simply phi minus theta by omega d. Phi minus theta by omega d. Here see, here rise time tr equals to phi minus theta by omega d. Omega d means here damped frequency oscillation, that is the omega n into under root 1 minus zeta square, where theta equals to tan inverse of under root 1 minus zeta square by zeta, right? That is the theta here. So this is the formula for the rise time. Here next coming to maximum overshoot or peak overshoot. Maximum overshoot or peak overshoot, it is representing with the m suffix p, and it is defined as the ratio of the maximum peak value to the final value. Maximum peak value, here this is the maximum peak overshoot from here to here. So maximum peak overshoot is nothing but the ratio of maximum peak value to the final value. Maximum peak value to the final value, that is final value of c of t is equals to c of infinity, and maximum value of c of t is nothing but c of t. This is the maximum value, and final value is nothing but c of infinity. Here now peak overshoot m suffix p is equals to the difference of the maximum value of response or maximum peak value, that is c of tp minus c of infinity divided by the c of infinity. Here percentage of peak overshoot, just percentage of m maximum peak overshoot, that is into 100, just add the into or multiply with the 100, you will get the percentage of peak overshoot, right? This is the formula of peak overshoot or maximum peak overshoot, both are the same. And also one more formula for the maximum overshoot or peak overshoot in terms of zeta, the relation between zeta value. So in terms of zeta, that is the formula of m suffix p equals to, or percentage, e power of minus zeta phi divided by under root 1 minus zeta square, under root 1 minus zeta square, and multiply with the 100 because of percentage. So this is the formula of percentage peak overshoot or maximum overshoot. Okay, this is about the definition of the maximum overshoot or peak overshoot. The maximum value, ratio of maximum value to the final value, and always maximum peak value is measured from the final value only, right? Here where the maximum peak value is measured from the final value, that is the final value is c of infinity, and maximum value is c of tp, minus c of infinity divided by c of infinity, right? This is the formula of maximum overshoot or peak overshoot. Next coming to the settling time. Settling time, it is representing as the t suffix s, and it is defined as the time taken. It is defined as the time taken by the response to reach and stay within a specified error. It is usually expressed as percentage of final value. See here, observe, this is the settling time. Here settling time, the response, here see, it is defined as the time taken for the response to reach and stay at a specified error. Here allowable error is there, and or tolerable error. This one, allowable error or also tolerable error. Allowable error or tolerable error here. So the response of the system to reach and stay within a specified error, the time is known as the settling time. It is expressed in terms of percentage of final value. the usual tolerable error is 2% or 5% of the final value. We have a two tolerable errors or allowable errors. They are the 2% or else 5% of the final value. For the 2% of tolerable error or allowable error, the settling time is T suffix s is equals to 1 divided by zeta omega n. 1 divided by zeta omega n, where 1 with 2 for 2% it is the sorry, here see 4, this one is the 4 divided by zeta omega n. 4 divided by zeta omega n, where time constant T equals to 1 by zeta omega n, where time constant T equals to 1 by zeta omega n. This here substitute 4 by zeta omega n in place of T, zeta omega n, that is the 40 for the 2% error. Here the settling time Ts equals to 3 by zeta omega n, where 1 by zeta omega n is nothing but the time constant. It is the time constant, that is T, representing as capital T. Here 3 by zeta omega n, where 1 by zeta omega n is nothing but the T, and here 3T for the 5% error. All these are the time domain specifications which are gives the information about the response or performance of the system, performance of the any system. Here in underdamped system we have all the time domain specifications are available. When we are going to apply the unit step input for the system, at that time we are going to get the output as a response, that is C of T. In terms of we have a time domain specifications. All these are the time domain specifications like delay time, rise time, peak time, settling time, maximum overshoot or peak overshoot. All these are the time domain specifications, right? Time domain specifications of underdamped second order system for unit step input. Right? I hope you understood every definition. I think settling time, a maximum overshoot, the ratio of maximum peak value to the final value. Always maximum value or maximum peak value is measured from the final value only. That is the definition. Peak time is nothing but the response to reach the very first time up to here peak value or else the maximum overshoot or maximum value, right? That is the peak time. And rise time, simply the time required for the response to rise from 0 to 100% of its final value. That is the rise time. And delay time is nothing but it is the time taken for the response to up to reach the 50% of its final value. All these are the definitions of the time domain specifications. I hope you understood every definition or every point of the time domain specifications, right? Thank you one and all. Next class we are going to derive the some expressions of the time domain specifications, right? Thank you all.